Alright, with this video we're going to go over some of the exercises that were assigned for you in section 76. Mainly dealing with arcs of circles, arc measure and arc length. Okay, and of course we remember the distinction between arc measure and arc length. Arc measure is merely trying to find the measure of the arc in terms of degrees. Let me just pick up a pencil here to work with. Okay. All right. So in this case, since this angle, the central angle is 128, the arc is 128. And then, so CD arc would be its supplement. The supplement of 128 would be 62. And then this arc would be 90. And then this arc, of course, would be 90. Okay. And of course, as always, all the arcs of the circle add up to 360. And, you know, any of these is just looking for a particular arc, like arc BC. Arc BC is, okay, the minor arc running from B through D to C, which is 90 and 62 for 152, utilizing the arc addition postulate. And the rest of those arcs are found in the same way. For instance, arc TDC, TDC is basically the whole circle less that 162 degree arc. Okay, so in that sense, it's everything but that 100. So it's everything but the 128. So arc DC is 360 minus 128, right? So I guess that would leave it at 232 for that arc measure. Okay, down here we're asked to find the arc length. Now the arc length, remember, arc length is that fractional part of the circumference. So it's the angle measure over 360 times 2 pi r. So any one of these we're going to have to find the radius, okay, and then the central angle and the circumference. Okay, so let's take a look at this. We're asked to find the arc length of what's shown in red there. Okay, which we should determine is a 120 degree arc. So, and of course the radius is 12. So we go to our formula. We've got 120 over 360, which is a third, 2 pi r, okay, or pi d, whatever you prefer. So in this case, we can go pi d. So it's 24 pi. So it's 1/3 of 24 pi, which is 8 pi. So that's the arc length associated with that red arc right there. Okay, excuse me, I'm going to take a pause here for a minute. We'll come back and look at some of the... Okay, so we're back here. We're going to start looking at this other set of exercises. Okay, let's come over here. Find the indicated measure. Okay, so that's all these arc lengths. Okay, so they all add up to 360. Let's look here. Okay, we know we got a diameter here. Okay, separating our arc anyway around here to semicircle. So we've got, here's a semicircle is marked off. Here's 70 degrees. These two arcs are equal. They're equal at, and must equal 110, so they're 55 each. Okay. Okay, along here we have a semicircle here. Maybe do a little change of color just to highlight it. Okay. So here's another semicircle right along here. That was 70 degrees, so this is 110. Okay. And another semicircle here in green. Here's another semicircle right along here. Okay, this was 55 here. So 55 and along here, I'm sorry, here's 110 here. Of course, here's 70 then. And of course, there's any other number of ways of getting that from vertical angles and the likes, okay? So some of that will come into play down here. Let's take a look down here, okay? So, what about these? 52. Well, find the value of each variable, okay? You got a semicircle along here and along the bottom. So the arcs C plus 4C minus 10 equals 180. Simple enough to solve. All these arcs, that is, arc PQ plus arc QR plus arc PR is equal to 360. So just throw the terms in terms of x and solve for x, okay? Find the length of each arc shown in red. Okay, let's do this guy here, all right? So the arc, again, we're looking for the, I believe that we're going to be looking for the arc length, okay? So we're going to say it's a fractional part of the circle, all right? And we can easily find any one of them. So what would be the measure of what we're looking for? Okay, well, here's 45, so that's 135 right there. 135 is that arc right there, that angle right there. Okay, so we're looking for the arc, which is everything but 135. Okay, so we could find the arc at 135, or we could subtract from, we could say what, it's 360 minus 135, okay, which of course would be what, 225, okay, so then I'd say what, I'd say, all right, this arc is a fractional part, it's 225 over 360 times 2 pi r, where the radius is 4.1, so it's 8.2 pi. So there you have it. That's your procedure for going through that. Okay, and you simplify that and leave your answer in terms of pi for each one of those, and then you're done. Okay, so that's a review of some of the problems that were assigned to you in section 7.6. Okay, just follow my lead on the ones I've done, and you should be able to complete the rest of them. Okay, there you have it.